Hi and welcome to my presentation. I want to talk about using a content delivery network without having to trust their admins. We will do that by using Subresource integrity, which is a W3C working draft. And it helps you verify that scripts and styles that you include in your web page has not been modified. Throughout this talk, I will talk a bit about CDNs, about the browser security model in general, about the security considerations for using a standard like this, and a feature roadmap for the specification. I will also go into adoption of this standard, but later on. Something very short about myself. My name is Frederik. I spent my time analyzing, reviewing, breaking, and securing software at Mozilla. I also mentor newcomers who want to work on free software. If you have any questions about that, I'm also happy to answer them at the end of my talk, as any other questions as well. So something about why I'm here. Mozilla as a non-profit organization is guided by 10 principles, which we call the Mozilla Manifesto. My work is more or less oriented about principle number 4, which says, and I quote, individuals' security and privacy on the internet are fundamental and must not be treated as optional. And that brings us to content delivery networks as well. Maybe show your hands who has seen code like this. I'm expecting more hands, but I think everyone. What does it do? I mean, from a developer, from usability perspective, it means high performance. It means there is a geo-distributed endpoint, likely using DNS-based optimization. The requests toward this resource are slimmer than to a resource in your own domain because there are no cookies associated with it. It is very likely that this is already in the browser cache of the user coming to your website, even if they've never been to your website, because a lot of websites are using content delivery networks. And the more websites use this specific content delivery network, the more likely is it that you have better performance on your website because it's already in the cache. But what it means from a security perspective is mandated by the same origin policy. And I will dive into what it means exactly. An origin is basically the scope of your web application. An origin is the scheme, the host name, and the port of a URL, and we take that as a criterion to compare to web pages. And another oddity of the web that we must know for this presentation is that you can execute JavaScript from whatever domain, from whatever web page, in your web page, but the same origin policy, as I said before, doesn't allow you to read it necessarily, right? Because the domain's code.jquery.com is not your domain, so you can actually fetch it using JavaScript APIs and read it, but you can execute it. The same origin policy mandates that everything on your scheme, host, and port is accessible to JavaScript APIs. And it explains what the scope of your application is. And that includes that an attacker or any kind of JavaScript that you're including into your web page can inspect every other web page on your origin using subtle background requests with the XML HTTP request API. They can also open iframes to other pages in your origin and look at forms and see if a user interacts with them and hook into them. Of course, using the same origin policy, you can also lift basically the restriction on cookies to be bound to a specific path, because you can open a pop-up or an iframe that shows a different path and then just look at the content document.cookie attribute. JavaScript on one page can also use and abuse all the permission the user is granted for your origin, which is, for example, push notifications, geolocation, etc. And to highlight how bad this can be, there is an attack or a tool from 2010 from Christoph Kotovich, who's sitting right there. And it really emphasizes the danger of cross-site scripting in general. It's quite a nifty attack, and it basically means you have one attack on a web page on your domain, and it pollutes your whole domain. And the idea is to open, like, assuming vulnerable pages, I don't know, about.html, and the attacker is, of course, interested in login.html. And what they can do is they can frame the login page and maximize it, and the user is actually on the login, not on the login page, but he only sees the login page. And using the HTML5 push state API, the history API, the URL will be modified, and it looks as if the user is on the login page. And whatever he does, every event on the input fields can be hooked by JavaScript, of course. That means that one vulnerability is enough to persistently trap your users into an attacker's control. And why am I telling you that one vulnerability is enough? Well, unfortunately, because there are vulnerabilities on the web, and only 2014, jQuery has been compromised, according to this blog post, twice, which is quite bad, right? You don't want to use a CDN that may be compromised and then pollutes your whole origin. There is another security problem with using a content delivery network that isn't directly affecting only your website, but the web in general. Who's heard about the DDoS against GitHub a few weeks ago? Okay, that's most of you. What they did was very smart. They basically compromised a very popular JavaScript resource. I think it was the Baidu China counterpart of Google Analytics. And everyone who tried to fetch this JavaScript, regardless on what web page they were visiting, was intercepted using some sort of man-in-the-middle attack on an edge router from traffic coming from outside of China to inside China. And they served them malicious JavaScript, and no matter what web page they were using, which was using this specific CDN, the user being affected by this malicious JavaScript was basically turned into a bot. So you get a free botnet when you compromise a CDN. And all the bot was doing was DDoSing GitHub, but instead it could have served like malware to attack all the users directly. So by just compromising one single resource like this JavaScript file, you can affect hundreds of millions of people. And to me as a security engineer, this reads a bit like, dear burglar, here's the combination to our safe lock. Please don't wake me up. But it's not a hard security problem, right? When we create a web page, we know exactly what kind of resource we want to include in the web page, namely just jQuery or any other kind of library. We don't want to execute arbitrary scripts from this CDN within our origin. So what if there was something that allowed us to verify the script before actually executing it? There is now. This mechanism tells the browser to just conditionally include something, only if the resource contains exactly what we expect. And it's called sub-resource integrity. I've been working on this for about a year and a half with a few colleagues of mine, François Marier, Devdata Arcave from Dropbox, Joel Wienberger, and Mike West from Google. And it's a W3C working draft, which we want to release as a recommendation very soon, which means if you have any feedback, any comments, any ideas, we want to have them now. It's in the wide review state, and browser implementations are basically there. So how does it actually work? We basically make the script tag a bit longer. By the way, the green ribbon in my presentation means this is in scope for the sub-resource integrity specification version 1. We will have a version 2, which I will talk about later, or 1.1, I don't know. So we will look at these attributes step by step. First of all, there is, of course, an integrity attribute. It contains the digest of the JavaScript file. And let's quickly recap what gaining integrity using cryptographic hash functions actually mean. There is a very common use case, which you've probably all seen, and you can check for accidental data corruption when you download a large file. The idea is that you download a large file, and then you compute the digest over the file you received. And then the person who is publishing the file also publishes the digest of the file, and then you can see, is it the file I intended to get? This is using a cryptographic hash functions, which basically does some input in variable length, some input out static length. And changing just one bit in the input would give you a completely different hash output. And it should also be very, very hard to find two inputs that give you the same output, which is called a collision in cryptography terms. That means we want a collision-resistant hash function. In our use case, we do the exact same mechanism we use for downloading large image files and apply that to JavaScript. That means normal JavaScript, good JavaScript, jQuery in this example, this digest, different library, different digest. So we can just detect failure and easily prevent any kind of malicious modifications. Of course, it doesn't work if the hash function is broken, but if a hash function is broken, we probably have more and bigger problems than compromised CDNs. But wait, didn't we say we can't really read stuff that is on another origin? So can we at least know the hash of something that is on another origin? Let's think about that for a while. assuming there is a JSON endpoint that is more or less giving you the authentication status of someone logged into the service. An attacker could, of course, include this because JSON is also valid JavaScript. And the user session cookies are always sent when you request a script, right? So an attacker could do exactly this here and compute the integrity value for the response Alice, for the response Bob, etc. And he will see by on error or on load events on the script tags whether he has succeeded and he can identify the user. This would be really bad, right? It could be even worse with routers or some other appliance in an intranet that you would then also be able to reach through the victim going on an evil page. Especially because for a home router, the defaults are widely known. Most users don't really change the passwords, and deploying security updates for them is really hard. So we can't really allow that. And what we do instead is we use cross-origin resource sharing, which is also called CORS. And it is a way that a website can say, this is a public resource, everyone on the internet should be able to read it, regardless of what the same origin policy says. So if we recap, we can use, for example, XML HTTP request to get a resource on a different origin. And it would somehow look like this. But if the origin doesn't opt in to resource sharing, if it's not a public resource, for example, your home router or this JSON endpoint, you will get an error that basically explains how you would do it correctly. It says the cross-origin request was blocked. The same origin policy disallows this. But if you want to use it, the endpoint at, in this case, example.com, has to add a header called access control allow origin. And this is opt-in, right? So by default, everyone is safe. But if you want to make your resource public, which content delivery networks, of course, do, you just add this tiny header. And by default, it's basically accessible for everyone. Not by default, by including this, it's accessible for everyone. And the CORS header, in this case, only allows anonymous access. That is, do not include cookies. So it's basically like executing curl in the command line. You're really just fetching some public static file from another origin. So that is the second attribute that I was showing in a slide earlier. The cross-origin anonymous attribute basically says, we only want to load this file if it's CORS enabled and we want to fetch it anonymously. That means without cookies. I would assume that the browser will not allow integrity checks when there is no cross-origin attribute or no cross-origin resource sharing on the server. But I include this specifically in the script tag here because for the sake of the presentation, I would prefer clarity or conciseness. So when you do all this, there is, of course, a lot of tiny details that I also want to go into. The fine print is not always as easy as it seems, right? We're really just checking a hash, but what does it mean? Of course, there's a syntax. I suppose you've seen this, but there's really not just a digest in the integrity attribute. There is a small microsyntax we've defined. And it's basically the name of the hash function, a dash, and then the actual digest. The digest is encoding using base64 just to save some bytes or whatever. And of course, you can use more than one token. So you can specify more hash functions or more digests or both. And let's go through the cases step by step. Of course, you can specify multiple hash functions for interoperability. And that means the browser will have to find out which hash function do I actually check. In this case, it's very easy, right? We would prefer the longer one because it's more secure. But it gets trickier for hash functions that have the same output length, but are from different hash function families. In this case, it's really like not my choice to make, right? So in the end, the browser will implement which one to prefer. And then you can, of course, specify the same hash function family, but different hashes. Why would you want to do that? Well, assume that the resource you're getting is different based on browser sniffing or content negotiation, or maybe you're expecting a new jQuery version to be released and the hash is already public, or there is an old one that may also be accessible. So you can just put in both and it will load because one of the hashes will actually work out. And if you want both, like different hash function families or hash function lengths, and also fallback to multiple resources, you basically have to add 4 hashes, that is 1 per resource per hash function family. Now, what would we do if a hash function becomes outdated or broken? That is also for the browser to decide, right? He can mark hash functions as usable or broken. In the very current case, we really only support SHA-2 with output sizes of 256, 384, and 512. But at some point, something may be broken, and we have to think about how do we secure that from a specification perspective. I think, and I'm not entirely sure about this, but this is the feedback we got so far, we cannot really break unmaintained site, right? Unmaintained websites. So if at some point somebody wrote a web page using sub-resource integrity with an insecure hash function, and later the function becomes insecure, we can't really just make the site not work at all. So instead, we probably have to alert or warn that integrity couldn't be verified completely, but the website will still work. We're probably not going to surface this to the user, but do it in the developer tools because users don't really understand hash functions. The next question is, do we want to do all this over HTTP or HTTPS? I mean, obviously, we want everything on HTTPS forever because it's better than HTTP and confidentiality and integrity and authenticity. But the main use case of sub-resource integrity is really just protecting my website from a compromised content delivery network. And this would all work very fine over HTTP, right? So the webmaster can protect their website from a potentially untrusted CDN using sub-resource integrity on HTTP. But we cannot make really any guarantees that the website you are creating and sending to the user is going there unmodified with all the integrity attributes in place. So if you want to think about network attackers and other attacks, you probably want to do HTTPS. Because sub-resource integrity is really just integrity, and HTTPS is confidentiality, integrity, and authenticity. Next up, I want to talk about failover. What do we do if the resource didn't load? What do we do if we block jQuery and our page doesn't work? Well, yes, an evil script was blocked, that's great, but then nothing works. That would be not really great. So instead, we want to recover from this failure. And how we can do this for now is using some sort of manual error recovery. You just check if window.jQuery is falsy or truthy, and if it isn't included, you just include something else from your own origin, which you should, for multiple reasons, always consider as safe. This is, of course, slower, but it's guaranteed to work for the user and not be insecure. Next up, I want to talk about future work. Things that we are thinking about how to extend sub-resource integrity in the future. This part is still in flux, so I really want feedback on the next steps. And as you will notice, there's a red ribbon in the corner. That means this is not part of any kind of specification. It may change, it will change. This is just ideas we're having right now. So, for example, we're thinking about built-in error recovery to make this all a bit nicer. For example, with an attribute called fallback source that points to something else that is always considered trustworthy. I will repeat again, this is a draft and the actual syntax may be different. What we also had in a previous version of the specification, but we killed out because of complexity and we already, without all the extra features we're thinking of, we can secure content delivery networks. So we've also been thinking about integrity policies tied into content security policy. Basically saying, hey, I want everything to block if it doesn't check out, or I don't really want things to block if integrity doesn't work. I just want the browser to report to me that something was fishy. The integrity policy could also mandate that all sub-resources should come with an integrity tag. And if they don't, just don't load them. That means there are more use cases than just scripts, right? Could also be interesting for styles, which is in scope of version 1. Styles are particularly interesting when you think about scriptless attacks, which Mario Heidrich has been publishing about recently, or not that recently, but still, in a paper called Scriptless Attacks, Stealing the Pie Without Touching the Sill. The slides are online, it's on YouTube, etc. Very interesting stuff. You can do attacks without JavaScript, and we can even protect against modified stuff using sub-resource integrity if you use style sheets from a CDN. In the future, we would also like to support other sub-resources. But how would this work for videos, right? I mean, a video means loading a very, very large file. So do we really want to compute the digest over a big, large file and then start playing it? That doesn't sound really cool. So that means to support integrity for something that is streaming, we need some other kind of integrity verification scheme than just publishing the hash of the file. That is something we've been looking into, but it's really tricky to get all the fine details right. We are thinking about doing something with Merkle trees. So if you're interested in streaming and integrity and cryptography, come talk to me. This could be interesting. In general, what I want to say is we need your help, right? I want to figure out how to prioritize things. I want to figure out how meaningful this is to developers. And you can reach out to us by, for example, looking at the W3C editors draft, which is hosted on GitHub. It has a link to the mailing list. It has a link to my email address as well. You can file bugs with a specification if you find some. Any kind of feedback is really appreciated. We also need tool support, right? Computers are very, very good at computing hash functions, but humans are not so great with it. And you don't want to go into console and to copy-paste of hashes. And nowadays, there are a lot of front-end build tools to manage your scripts and styles and resources for your web page. For example, Bower, Grunt, Gulp, NPM, etc. And sub-resource integrity is not yet fully supported in any of them, which is something I think we need to change. I've seen some basic libraries for both Gulp and NPM, but more support is needed, and any kind of help on this front is really appreciated. Lastly, I want to call out to all content delivery networks, please enable CORS. It is not harmful for you. It is beneficial to the developers and the users. Fortunately, a lot of CDNs actually use CORS already. The one I've been using in my slides actually didn't for a long while, code.jquery.com. But I talked to the jQuery guys. They're really, really nice to work with, and they just enabled it recently. So you can use sub-resource integrity in all the examples I've been showing you. To conclude, you can soon add integrity to secure script loads. You could actually do it right now, but this is just a specification draft. So if you do it now, you should probably monitor the draft and interact with us to make sure that things don't really change in the future before we are completely finished. What I learned for myself is that extending the web is not really that trivial when you think about these cross-origin leaks. Even when you add such a simple feature as just checking the hash of a file. And next up, I want to end with saying browser security really needs to step up, and I hope it will. The web is becoming more and more feature-rich, and it's touching more and more platforms. For example, unfortunately, yes, your car, flights, in-seat entertainment, we know there is no air gap nowadays. Mobile phones, etc., etc. And I hope the browser can help making the web a bit more secure. That's it from my side. Thank you very much for listening. I also have to thank my colleagues and co-workers and the people I've been collaborating with on the W3C mailing lists and within the Web Application Security Working Group. Thank you very much. I'm happy to answer any kind of questions. There's a microphone going around if you want.
For some questions or feedback on specification.
I have one comment and one question. The comment is for many CDN customers, I guess they don't want the star there in the CORS policy because they're paying for the amount of data that they're serving up. They want it served for their domain rights. And then the question is around canonicalization to be able to calculate these hashes in a robust way. Have you had problems, cross functionality between browsers, and how finely do you need to spec that?
Yeah, so first of all, to your comment, yes, of course, you can use CORS in a different way, but the public CDNs, which are open for everyone to use, they should use the star value, and they do that, and that's fine. If you want to do something more detailed, of course, you can do that. Towards canonicalization, we have thought about that, but it's really tricky to come up with, would you want to specify a way to canonicalize JavaScript files or CSS files or anything? So the thing is that in specification land, you want to build on something else because that means you have something which is already implemented somewhere which you can call as a function. And there is nothing like this before. And it's really, really tricky because we'd have to figure out at web scale how resources are modified between the browser and the website. In an ideal world, you would use HTTPS and it would just work, right? And nobody would modify it. In a non-ideal world, you would have a fallback that would use your own resource when the hash doesn't match. And then you'd have to investigate why people are getting something else than you're actually sending them, right? Because modifying usually doesn't happen in your application server or your web stack or your SSL terminator. They're happening somewhere in between the happy cloud and the, I stole that from you, sorry, the internet and the browser, right? So we don't really know. It's really hard to figure that out. But if there are like any kind of inputs you can give me to go into this in detail, I would love to. But I think canonicalization is for now not in scope. It may be at some point.
Okay, sure.
What I meant is you need to canonicalize somehow, right, to be able to stably calculate the hash yourself so that you can publish it in the attribute and know, or at least feel fairly assured that the browsers will come out with the same hash. They both need to consider white space the same way, carriage return, so we don't end up with Windows versus Unix problems again.
Well, that is actually for the most part, scope of HTTP, right? The very file you have on disk is usually not modified by a standard web server. It doesn't change new lines. And regardless of whether your browser is running on Windows, Mac, or Linux, it will treat the new lines it gets as new lines, no matter if it's carriage return or line feed. So you don't really need normalization. In specification land, what we do is, regardless of whether it's compressed or not over HTTP using, for example, gzip, we look at the actual resource, not at how it was transported. That is something we do. You can call it canonicalization if you want, but there is nothing much to it except that. But if you want, we can totally continue this conversation afterwards.
I have one question and one remark. So the first question was, if I understood correctly, or did I understood correctly, that if you specify multiple digests, at least one of them must match, right? That's the hidden logic behind it.
Yeah, well, first, there's an algorithm, and I'm not sure if I can capture it completely correctly, but first we figure out which hash functions we prioritize. And once we have done that, we figure the best and most secure hash function. We get all the values we have, which may just be one, and then this one has to check. If there are more than that, we check if either of them checks out.
Okay, okay. And the remark, the future idea of specifying the fallback resource, I don't really like it because it's yet another attribute name that allows you to fetch a resource. So yeah, for filter bypasses, this sort of thing, I would rather have it like programmatically just do the JavaScript.
That is a very good point, yes.
Yeah.
Thank you. There was another question back there.
Oh, okay.
So, is cause a requirement for the script?
Yes.
Right, that's all I wanted to do.
Should or could the advertising industry use this to finally kill their Achilles heel called malvertising? We all hate advertising, of course, but some of us get paid by them. I'm not, but asking for a friend.
I'm not sure. In theory, yes. In practicality, well, you usually don't handle ads yourself, right? It's all done by ad networks, and they include something. Even if they hash it, do you think they are going to review something before they hash it? Or I'm not entirely sure how this is going to work.
Maybe they could somehow sign their hashes, and you could check the signature of the hash. Maybe.
Well, as soon as we go into signing, we go into public key crypto, which means you have to have some sort of way to manage keys or find out if someone actually owns keys and stuff, which brings you either a PKI or something that is not secure, or well, a PKI is also not secure, but
Right, yeah.
that's really tricky, right? So that's why we just said, let's do integrity. We don't want to sign stuff because then we would have to discuss keys. But I think it would be interesting if we could solve it, but I don't think we can solve it for now.
Right, okay.
Any other questions?
Is there any browser support right now already?
Yes.
How is it?
If you get an unreleased that is nightly version of Chrome or Firefox, it is not enabled by default, but there's a switch you can do in the advanced settings to enable this. So we're working very, very close with the implementation from the specification side. And I think some web pages are really, really eager to use it, and they have done it in some sort of better way, even though they haven't talked about it yet. So support is coming. It's not completely there, but we are very, very close, and that is why we're calling for wide review for the specification, because we want your feedback now before we actually push the implementation to our end users in released version of Firefox and Chrome. I think it's under consideration for IE. I don't know what this means. I guess it means somebody suggested and they said neither yes or no. I guess Opera will get it because they take Blink. Safari, I'm not sure.
Hi.
Hi.
So have you imagined how deployment will work? Like, I can imagine that it will be easy for things like jQuery and so that have releases every once in a while as versions.
Yes.
But for other scripts like analytics or other stuff like that, they don't really. I mean, there is no versioning system. They just get updated every once in a while. And if someone suddenly puts an integrity tag, it's going to break in a couple weeks or so.
Yeah, so to recap, the easy part is probably jQuery because you usually bind your source code to a specific version, which is basically the URL, and you always get the same file. But if you have a file name that is jQuery.latest.js, for example, or Google Analytics, which changes all over time, it's very hard to figure out if something changed. So you could either do some sort of automation to like check frequently and hash frequently, but it's definitely tricky. You would have to solve it for yourself. It's not really part of the implementation or the specification. I think it could be doable, but it's definitely trickier.
Cool. You could use service workers.
Yes, you could also use service workers. But that's actually a valid answer for everything, right? You can now use service workers.
So as a security-conscious user of browsers, is there any indication within a browser that some resources loaded on this page were not integrity checked or that they were integrity checked?
No, specifically, no. It's really, really hard to explain logs to people, and logs are really just icons, right? I don't think we want to explain integrity and what it means from a cryptographic perspective to a user. So it's really, really in the hands of the developer of the website. They can do error recovery, they can do error reporting using standard JavaScript events, but they don't have to. There was actually, maybe this is interesting to you. You probably know that there is mixed content script blocking. That means if you're on an HTTPS website and the website includes a script which is just HTTP, it will not load and the browser will say, hey, something has been insecure and it may be modified, so I'm rather not including it. There have been suggestions to say, we really don't need to block the script if integrity checks out. But fortunately, from my perspective, everyone said no. And the reason is because of course, HTTPS, as I said earlier, is not only integrity, but also confidentiality and authenticity. So we will continue to block mixed content scripts, and we will not allow to weaken this using, for example, integrity. Okay, thank you very much. If you have any further questions, let's take them outside. Thanks.
Please don't forget